In this lecture we will talk about recycle reactor. What we mean by recycle reactors, sometimes we need to do a mixing, and we know that in mixed flow reactor, either batch or continuous, we know that mixing is approach to infinity, but in plug flow reactor mixing is 0. So in some kind of reactor we need to do mixing between 0 and between infinity. So I think we talk here about a plug flow reactor. We need to do a mixing so to control temperature in the reactor, or sometimes, let us say in biochemical, we need to ensure the completion of bioreaction, so we have to use recycle. Let us now imagine this is PFR, and when I say PFR, it's still PFR. There is no mixing in the axial direction, but it is mixing in radial direction. So if this is FA naught here with CA naught here, and this is initially, and here is FA naught also. In this case, for steady state, and this is our recycle. This will be R multiplied by FA naught, and we know that recycle is no more than volume of liquid recycle over volume of liquid withdrawn from the reactor. We know that also if delta B is constant, we know that means it is steady state. So how to check delta P? You learn that in the second class or second stage at fluid flow. So after reaching steady state, so I'll redraw this figure, and this is FA naught, XA naught, V naught, and at this point we will name it O, this point name it K. Here we have FA final, XA final, V final, whatever. So from this point we will take our recycle to this point. So indeed, when we have V here, this V will add it here too. So we'll have 2V here. So at this point we have XA2, FA2, V2. So here our recycle is R, VF, and FA3 equal to R, FA final. Since we know that recycle is FA3 over FA final. So what means recycle here, flow rate of this stream over flow rate of this stream. Now if we want to write FA Here we have this point, we have FA naught dash, which is equal to 1 plus R FA naught, and here FA naught plus FA naught R, so FA naught will be 1 plus R FA naught, and that will be named as FA1. Here XA1, here will be V1. V1 will be V naught plus V recycle. So FA will be FA naught dash 1 minus XA for stream A, and this is equation 1. So minus DFA will be minus RA dV, and this is equation 2. So minus RA dV equal FA naught dash dXA, and this is equation 3. So V over FA naught dash will equal to integration XA final to XA1 dx over minus RA, and this is equation 4. We're talking about input to this point and exit to this point. Here after mixing, here before recycling over. So from this equation we can see that XA1 is FA naught dash minus FA1 over FA naught dash. We know that XA1 here is FA naught output would be FA naught dash minus FA naught over FA naught dash. So this will be equation 5. Now let us write this. FA naught dash will be equal 1 plus R FA naught, and this is equation 6. So FA1 will be FA naught plus FA3 and equal to FA naught plus R FA final, and this is equation 7. So XA1 will be R over R plus 1 XA final, and this is equation 8. Now the final equation, we will have V over FA naught equal R plus 1 integration XA final to XA1, which we found that it is R over R plus 1 XA final dx over minus RA, and this is our final equation for recycle, which is the equation 9. So if you want to, I want from you to read this process and how to get this equation. This is very important, and I think it will come to you on exam, next exam or other exam. If we now try to represent this as in figure, let us say this, and we have here XA final, and this is 1 over minus RA. So if R equal to 0, there is no recycle, area under the curve will represent V over F A naught. Only there is no R. So area under the curve. But if R have some value, so I'll write this equation, V over FA naught will equal R multiplied by integration plus 1 multiplied by this integration. So you can see it will vary from R0 to a given value, and if I represent it like this, so here XAF and this XA1, so this area belongs to the 1 and this area belongs to the R multiplied by this. So it's somehow like this. Even R small will go in this direction until reach plug flow reactor without mixing, But with exist of R, we expect that it's somehow turned to a CSTR reactor. And this is 1 over minus RA average, and this is area multiplied by XA final. So this is X, and what we mean total area will equal to 1 over minus RA multiplied by X AF. So this is X and this is Y. So depending on R, if we have a small r here and this figure, if we have here R, the other thing will be 1. So you have to read this lecture carefully, and you can go to